The Office of Accountability and Compliance would like to thank all of you for coming out to talk about ethics. This is National Ethics and Compliance Week. We've had different activities on campus. If you haven't seen us yet, you will be. This is being recorded so that if you want to share it with your friends, feel free. On our website, we also will be having other interesting things such as podcasts with different champions from the campus. So since we're a little bit behind, I'd like to introduce Dr. Bob Ernst from the School of Dentistry. He's a professor, and he is also on the Judiciary Committee, head of the IBC. I borrow him for inquiry committees from time to time, so he's all over the place. So please help me welcome Dr. Ernst.
Good morning. This is as many of you who know me, this is a very bright and early morning for me. But I'm glad that you guys all showed up. So when Sarah came to me, she inquired if I'd give a lecture or a seminar on ethics, but ethics in the context of a researcher. Because one of the things, I'm not a physician, I'm not a dentist, but as a researcher, I've gotten myself into quite a few things here on campus. Gotta make sure I use the right one. As Sarah said, I'm professor and vice chair of the Department of Microbial Pathogenesis in the dental school. I am the chair of the Institutional Biosafety Committee. I'm a member of the School of Dentistry Judicial Board, the UMB Inquiry Committee that Sarah runs. I do lecture in the ethics class, and I'm also a founder of a small local startup company, which allows me to talk a bit about the Office of Technology Transfer and also conflict of interest. And that'll be part of the latter half of this talk, is trying to understand COI, which is not a simple thing sometimes to work through. So UMB has a very set code of ethics and conduct, and you can see it, parts of it here, but you can go online. It's if you put in UMB code of ethics and conduct, you can download the whole code. So all UMB personnel are subjected to this code. It's not just students and postdocs and faculty, it's all the employees, all the students, and all the volunteers too. You know, we have a lot of people in our labs who do want to volunteer. They come in as undergrads, they come in as sometimes high school students in the summer, and they have to follow the same code that we all follow. And it's one of the jobs of a faculty member or a student or a postdoc who have these students working for them to make sure that they are safe, ethical, and they're not doing anything that would kind of embarrass what the mission of UMB is. The code also reflects all the laws and policies that relate to ethical conduct at the state level. So we're not just a campus thing, we are also a state level institution. So if you go online and you can look all these things up, they're very long, they're very arduous, but they may change, we'll see. One of the things you can see at the bottom of this while it's trying to think about changing is that there is a hotline. Some reason, because of the transfer between the Mac and the PC, my little yellow box moved a little bit down. But if you click on the hotline link, it will take you anonymously, or you can do it with your name, and you can explain or say, I think something might be going wrong. And if it's at the school level, it might come to the School of Dentistry for the start of this. If it's greater, then it'll go to Sarah's group. And then they can evaluate it, whether it needs to go even larger or escalate to an inquiry committee or something like that. So these are the 6 codes, and these are taken straight off the website, and it's to uphold the highest standards of intellectual honesty and integrity in teaching, research, service, and administrative activity. The simple message here, the take-home message is, if you're a researcher and you have questionable ethics, you're not really a researcher, because nobody will understand, nobody will trust, nobody will fund your work, and literally all you'll be doing is you will be in your office doing nothing. You have to act as good stewards of the resources entrusted to you, the researcher or the whoever, by UMB, because again, what you do affects this campus, and if it affects this campus, it affects the entire system. You have to comply with all the laws, rules, regulations, policies, procedures, and professional standards. And physicians have different sets of professional standards. Researchers, dentists, hygienists, and administrators all have their own code and professional standards that are on top of whatever the state says you have to do. You also have to comply with the assigned and assumed responsibilities. Those are also outlined in many of the documents that you can receive when you're first hired, And if you need more training, there is lots of training available on campus to refresh what are your assigned and assumed responsibilities. This one is actually very important. You have to disclose and avoid improper or unlawful conflicts of interest and conflicts of commitment. One of the responsibilities is if you see it, you're supposed to disclose it. I know a lot of people don't want to be involved in XYZ, but at the same time, if you're not involved in XYZ and you let something happen, you're culpable for what could happen, especially if it's dangerous to a student or a postdoc or somebody else and somebody gets hurt. And then you're supposed to report known and reasonably suspected wrongdoings. And a lot of times we see them through the integrity office as anonymous. And what happens is we get an integrity committee together, we review all the information, we say, yes, it can go forward, no, it's really nothing, and then it goes back into another committee, and it's really handled very administratively well on this campus because there is no judgment a priori that you did something or you didn't. You just come in and we have a conversation about what you may or may not have done. And that makes it very simple to get down to the bottom line of what really happened. So very simply, I don't know where I am in the this is Wednesday. I don't know if we've had 2 other ethics talks, but what is ethics? But more importantly, why is there a need to talk about ethics? Why is there a whole class in ethics for students and postdocs? It's because sometimes there is black and white ethics, and sometimes there's gray ethics. And sometimes it's really hard to figure out what the gray ethics are until you're taught by example, authorship, or what should be published, or what's a good experiment, what's a bad experiment. And a lot of that is your training as you go forward in graduate school, and even as a postdoc, because you don't know how to design the best experiment. You don't know how to do the best work. You don't know how to evaluate your research to the fullest extent until you gain, some of this experience as you go forward. And even now, I've been doing this for quite a long time, and I am challenged on how I do my experiments by students because students are smart, postdocs are smart, and it doesn't mean I know everything. The whole idea here is that it's a give and take, and we work together to go forward. So, stole a couple simple things. Ethics is the disciplined study or morality, and morality asks the questions, what should one's behavior be? And this doesn't have to be, when we're talking up here, this doesn't have to be a one-way thing. If there's something you want to ask, raise your hand, yell out a question. It doesn't really matter because we have plenty of time. And then ethos or ethics is really character. And that's really what we're talking about people, is that when we bring in a graduate student, we invest $250,000 in their education minimum. So you want to bring in smart, energetic, and people with good character. So this idea is that we invest money, and it's not my money per se, it's the government's money, it's NIH's, it's the state, it's industry's money. So we have a responsibility not to waste that money by training the next investigators. And we're not really training the next investigators, we're training our colleagues. The whole idea is I'm trying to put out people who I want to work with as I go forward in my career. And that's really the important part of what we do as researchers is, yes, we do some great stuff in the lab and we publish papers and we get recognition for that. But a lot of times the best recognition is people who go out from your lab and do greater or better things than you could ever have possibly imagined. And that's what really makes you feel good. So the concept of good, bad, right, wrong, they're not black and white. They're gray. Because everybody has a different concept of what's good and bad and right and wrong. And that's kind of why we have these ethics trainings and we have these ethics classes, because some people may have an idea of what good and right and wrong are, and scientifically they may be clear as day, but in a non-scientific setting it may be slightly different. So what we have to do is we have to figure out what is right and wrong and then apply these general principles to justify why you think this way. And just because someone says you're right or wrong, if you can justify why you have these thoughts, and this is why you're thinking, or this is why you want to go down a specific path, then I think that's the conversation that gets you to, really an education on ethics. So there are really 2 types of ethics. There's descriptive ethics and there's prescriptive ethics. And descriptive ethics asks, what does the culture or society believe is morally correct? And this is a really tough one right now, because we as scientists do things empirically. We study, we get a result, we do it again, we try to confirm it, and we put it out into the literature and we say, X, Y, and Z is good for you. Well, there's other people in the community who say X, Y, and Z does harmful things to our X, Y, Z children or families or whatever, with no empirical data, and all they're saying is circumstantial. I did this and this happened, so therefore this must have caused this. But there's no real connection between this and this. And I'm trying not to use an example because, I don't know who will be watching this in the future, because there's very simple things that are happening right now in the general community that the scientific community says is absolutely important for health and safety, but it's being lost in the discussion sometimes. And then there's the prescriptive, is how should I behave as a researcher, and what characteristic traits should I cultivate both in myself and everybody else who comes through my lab or I come in contact with. And I guess this is kind of, again, going back to why we're giving these lectures to prescribe these ideals and characteristic traits to, in my personal opinion, what I believe is important. So, 2 types of ethical decision making: deductive or principle-based, or inductive or case-based. So I am kind of going to walk up to a little bit of clinical research, but I'm not going to try to go into clinical research. I don't do a lot of clinical research, so I don't really want to speak about an area I don't know. So a lot of what I do is more principle-based and what's happening in the lab and understanding there. So deductive or principle-based reasoning starts with a theory, an idea, and this is kind of what happens in the lab. I think this will work, therefore I should try to figure it out, and let's see what happens. So you start with an idea, you continue with specific principles, and your specific principles can be just your methods and your protocols and what you want to do in the lab. You develop your rules. Okay, if I see this, this is what I expect. If I don't see this, what else do I have to do now to rethink this process? Because sometimes the simplest experiment comes out and it turns out positive, it's beautiful, you get all the data you possibly wanted, and that makes very simple science. However, what happens is if something comes out as a negative, it doesn't work. Was it a negative or was it a failure? And in science, we fail a lot. At best, I've told people in my lab that if you have 3 good months a year, you've had a great year in science, because the other 9 months are going to be failure, repetition, or, as an example, I was doing something for 10 years. It was working perfectly fine, and then for 3 months it stopped. No idea why it didn't work. And then 3 months later, it picked up again and it worked again. So in science, it's more about understanding that when it doesn't work, how can you fix it? And how did you fix it? Sometimes it's a logical thing. Sometimes it's like, I have no idea, but it's back to working again. So science can be extremely frustrating. And then after you develop your rules of what, if this, then that, then you make the judgments of what your data was. And sometimes when you do that, that moves into the case-based part of ethics. And then the case-based is decisions we have made are precedent. I've been doing similar things for 20 years. Therefore, I can be the only one that's right. No. Every now and then somebody comes through and shakes you and goes, that's not, you see some new technology come into science. You see some new idea come to science, and it changes everything you just thought about. And you have to go back and look at your life in this part of your research and go, okay, part of this is good. Part of this was, I think we made some left turns here, or right turns here, and this is where I need to go. So you have to look back at your decisions and never be so ingrained that, so boneheaded that you're the only person who knows something, because there are so many more people doing science. We are not just, science in Baltimore. We are not just science in USA. We have science now all over the world, with China and Singapore and the Asian countries coming through with a lot of money and doing phenomenally good science on a bigger scale. And sometimes science is very simple. We think too small until someone comes and shows us the giant scale, and we have to come back and rethink what we were doing, because how can we take some of this information in the whole global sphere of science and bring it to Baltimore and in my lab, specifically. So judgments reflect back on our rules, and that's science always reflecting back. There are thousands of journals and thousands of papers that come out every year, to the point where you don't see them all. But then every now and then you find one of these. And a lot of times, if you've got great people in your lab, your student or your postdoc or somebody in your lab will go, hey, did you see this paper? And you're like, oh, no. And then that opens up a whole other discussion of what they should be doing, what we should be doing, or what we could be doing in collaborative science on campus itself. So all these principles reflect back on ethics. Because if you shortcut any one of these and you allow your strong feelings or what you think is right or wrong science to overwhelm what is really ethical, you get yourself into big trouble. And sometimes it shows up in falsifications of papers, falsification of data. I sit on these committees with Sarah, you don't want Stefan or people in her group to come through and look at your data with some of the computational and computer means that they have. They will find your mistakes. So, decisions, conflict between decisions, there will be conflict. I have no issue with conflict with people in my lab. The idea is if you come to me and you want to say something, we'll have a discussion. Many times I may know more because of just years in science, and sometimes you're right. And we've gone into a different direction, or we get to a détente, and then we go forward. You'll use both types of ethical decision in making your decisions because you have to. And when conflict arises, go back to the original principle. Go back and rethink everything from the beginning. And if that doesn't work, there are people in your department, in your school, on your campus who can help you solve some of these ethical dilemmas. Because sometimes you get to an impasse. And we do this, we write these, when you write an NIH grant, you do a multiple PI grant, you have to write a section on how you're going to resolve conflict into the grant itself. So that when the reviewer reads it, okay, I'm in school X, I'm in school Y. All right, if there's a conflict between the two schools, we will escalate it to the dean of your schools, and if that doesn't work, we'll escalate it to somebody designated by each of the deans, not by the researchers, but the deans to resolve conflict. It's kind of an arbitration-ish process. So that's really important about what we do, is to make sure that all these things are discussed beforehand. Because if you leave it till after the fact, it can only get you in trouble. So what does this have to do with you, the researcher? Public perception of research, its benefits and its risks is shaped by the way research is conducted. And you can see it a lot now. A lot of times, people will go out there and they'll just say, hey, I just found the newest, greatest thing. And one of the easiest ones to say is, you know, people say if you change your gut, you know, microbes with from a skinny mouse to a fat mouse, the fat mouse gets skinny. That's great. It might be good science. But the way you present it to the world, now the first thing that everyone's going to say is, oh my God, I'm overweight, so the first thing I knew is I need to do is go get some skinny bacteria and I'll get skinny. There is no quick fix to any of this stuff. Is it real? Yeah, it probably is real, but it's going to take a long time to figure out what the proper bacteria were that were in that sample that did something to this mouse to make it skinny again. And I think there's a lot of work being done in this building, because we're in the HSF3, the Institute of Genome Sciences, that are going to define a lot of these new bacterial things, because everybody's looking for the bacteria that code us from top to bottom and inside and outside. And we don't know who it is, because if you just, and there's 20 people in here maybe, we're all very different. Everybody has their own system of bacteria, and we share them. And sometimes they're good, and sometimes they're less good. So the whole process is flawed, because we do make mistakes. Researchers should never be so arrogant to say that whatever I do is right, because there's always a process or the possibility that they could turn out to be, you went down wrong and you didn't do it on purpose. It's just something happened and the results weren't what you expected. So creativity is countered with skepticism. That's an amazingly good line for scientists. You want creative people in your lab, but everybody between themselves, I mean, you have to be your biggest skeptic, and then what you have to do is you have to present it to people, and then they're going to be skeptical, and then you're going to put it in a paper, and they're going to be skeptical, and you're going to write in a grant, and God, they're going to be skeptical with a success rate of grants. So, you know, you can't be hurt as a scientist by thinking that everybody hates me. Rejection in science is normal. You know, 9 out of 10 grants get rejected. Papers constantly get rejected, and you get a chance to revise them. So the idea is, what do you do with that rejection to go forward to make sure that your work gets done? New ideas are questioned and empirically tested. That's the nice thing. If you have an idea and you can test it, and the testing results in a paper or a grant, that means you've been validated to some degree. And must be able to convince others of your view of how it works. And this is one of the horrible things about some scientists, is that they can't talk to any general audience. So one of the worst things that we can do as a scientist is that if we talk to elementary school, to other scientists, we have to be able to communicate our ideas at the level that's required for them. If you can't tell your parents what you do as a scientist, you're not going to be able to tell the rest of the world what you do. Because if you constantly go home and your parents go, what do you really do? Sit down, have another conversation, because you just gave it to them 6 months ago or whatever, and you start again. And that's the fun part, is because we can do science in a bubble, we can stay in our labs, and we can do all the great things, but if you don't go out and tell people what you're doing, and like, here, you're not really doing any extreme value to science. You're taking a lot of money from the government or whoever's funding you, but then you're not disseminating your ideas. So this is what happens if you're an ethically insensitive researcher, it affects you, it affects your institution, and it also it causes problems to people who are trying to get promoted. And it's the last one that becomes an issue, because sometimes when your back is against the wall to go up against for tenure at 7 years, 6, 7, or 8 years, whatever, or you're running out of money, or your XYZ isn't happening, you start to change your ethics because you're afraid. And that's one of the worst things that you can do, and it happens a lot. And it's not you're a bad or good person, you just have people in your lab who need to be paid. You have people at home, you have a family, you like where you are, your kids are set in a specific school system or XYZ, and sometimes people's ethics can be less stringent. And a lot of times that's when people get in trouble. So there are 6 norms of scientific research that I consider. This one is the first one that's really a mix between both research and clinical research. You have to have a valid research design. You have to have competence of the researcher, because if I entrust you a project or someone else entrusts you a project and you don't have the competence, then whatever happens is not going to turn out well. So as a researcher, if you don't have the expertise or what you think you need to have knowledge in that area, then what you need to do is ask. There is more than plenty people on this campus. Literally, we are on top of each other because we are a city campus. We have no green space. And if you can't find someone to talk onto this campus, you haven't tried. You have to identify the consequences. In this case, if it's clinical research, what are the risks and the benefits? Because obviously you can't do anything adverse to the patient. You need to have the selection of subjects, and subjects can be people, animals, non-human primates, fish, doesn't really matter, just bacteria, or what cells you're going to work with. In the case of patients, you have to have voluntary informed consent, because the IRB, Institutional Review Board, will come and knock at your door very quickly. And then if anything ever happens, you have to have some compensation for injury. And this is one of the things we've been talking a lot now, because we would like to get samples from people's oral cavities to do microbiota studies. And if you identify that they have a specific XYZ and they didn't know it, are you responsible for them making sure they get treated? And that's really a hard call, because if all you want is a little piece of plaque or bacteria from the person's mouth, and you see that they have periodontitis, or you come into the medical school and they have some GI issue, as a researcher, you only want this little thing. But now you've identified something that they didn't know they had. So now who's responsible for making sure they get treated? And that becomes exquisitely expensive very quickly. So, scientific ethics. Science is a social activity. We share in these kinds of physics. We share on campus, we share off campus, we share internationally, we share at meetings, we share in high schools, elementary schools, all over the place. So it is a social activity. Science is based off what has been done previously. I had a friend who was a postdoc when I was in Seattle, who knew the literature for a good 60 years. And all he would do is go back and say, yeah, we saw that 60 years ago. We saw it descriptively, and we didn't know why. But if you know the literature, you can get so much more out of it, because everybody has done so much work. So why do we discount what happened yesterday when we can build on what happened yesterday? This is a big one, and I think a lot of the people I know's labs, students, technicians, postdocs, and PIs all work together. You'll see it a lot on our floor, and it doesn't happen in some places. We go only by our first name. We're not Dr. So-and-so, because literally we are one of you. I would prefer to be back in the lab doing work. I enjoyed being in the lab, but there's just no time. Results can have significant impact on society. We've had great things turn out: drugs, vaccines, antibiotics, social experiments, understanding about schizophrenia, to a lot of other diseases that we know what it looks like on the outside, but what's happening on the inside, what's physically happening on the mechanistic level that causes changes in the brain and things like that. And results can have a significant reward from society. You have prizes, and people are stumping for Nobel Prizes or other prizes that they can win, or you get to a meeting and your student or your postdoc gets a travel award, or you get the best poster or the best talk. And all of these things are great, because if you get these things, then it looks good on your CV, and it makes you rise more catastrophically fast. Science is frustrating. As I said, 3 good months a year, 9 good months of frustration. Experiments fail, hypotheses fail, disagreement with colleagues and competitors. You hope that the people you're collaborating with are your colleagues, but sometimes they turn out to be competitors. You just didn't know it because they weren't honest with you. We're competing for money. And a lot of times, if with money comes recognition, I hope most people don't try to go out and compete for recognition, because if you do good science, you'll get recognized not because of who you are, but because your science was good. And truthfully, if you get recognition from your science, it would be better if it went back to your students and your postdocs and people in your lab, because they need that recognition to go on and do better things. And your dependence on other people for your success. NIH, your mentor, your dean, your God knows, we could list everybody. From top to bottom, somebody is helping you along the way. So remember, so these 2 things, science is social and science is frustrating. The interplay of these forces results in hard decisions for scientists. How do I treat this data? How do I treat my data? Who do I share my data with, and who do I don't share my data with? How do my values influence my research? Everybody has different values. They have different religious ideas. They know different places in the world that they do work. A very good example is I had a pretty good stream of students and postdocs from Thailand. Certain times of the year, we do animal work. Certain times of the year, they couldn't touch the animals because there was something in the religious background that said, hey, they come in and say, Bob, I can't do animal work from X to Y. And I said, okay, fine. What happens after Y is done? He goes, oh, I'm good again. So it was just something between those times that were bad for their religious beliefs. And you just have to understand. The same thing is, I ask everybody who comes into my lab, do you want or not want to work with animals? Because again, there is something about, you can't force anybody to do the work that they don't want to do, because if you do, then the work is always going to be bad. Who should share credit for this work? And this is a problem, especially nowadays with collaborative science, is that if you don't broach the idea of who gets what credit, it can always only turn into an issue. So who's first author, who's last author, who's in the middle? If you have 2 students working on it together, you can have co-this and whose name goes first and yada, 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 because that's how everybody's recognized as they look at the list of names on a paper. Is there an honest error? Sure. Honest errors happen all the time. An honest error means that you did something, you didn't do anything to manipulate the data, or you didn't do anything to manipulate the experiment to come out to the idea or that result that you wanted. And then sometimes honest error is negligence. And yes, I'm doing 15 things at once. All of a sudden, I'm not really paying attention to this one, and I kind of short-sighted this one, but oh my God, the data came out, it's beautiful. How do I repeat it? But God, I really like this data. How do I do so? Because you don't know what you really did. And then there's misconduct. And misconduct happens a lot. And that's really sad. But nonetheless, this is the day and age when your back is against the wall, what do you do? So society and science is a big deal because non-scientists play an important role in accessing science. With the idea of open source science now, where any paper can be gotten freely on the internet, it's coming. Europe has now just made it so that by 2022, they will not fund any more grants that don't result in open science papers, period. So if you decide to put them in a publisher for profit, you will not get funded anymore in the EU. America's not so progressive in that right now, because we pay page charges every time we publish a paper. It's not as though the papers are free. We pay anywhere from $100 to $500 a page, depending on where you are and depending on what the level of the journal is. So you're actually sometimes paying more money to get into a better quality journal. And more social importance equals more accountability to society. Non-scientists should keep us on our toes. They should be asking us questions. But at the same time, you see it in the physician or the dentist world. I think I have this because I went to the internet and the internet said I'm dying. And you have a hangnail. So again, sometimes people overreact just a little. So individual knowledge versus collective knowledge, and this goes again to the idea, it used to be that you could be your own island. You know, this half of the room would be doing one science, and this half of the room would be doing a completely different science, and all of a sudden, you should really be doing collaborative science, because nowadays technology is expensive, science is expensive, so why should I go learn a new, brand new technique, bring it into my lab when I can bring in a seasoned, excellent researcher to do it together? And now instead of one idea and two ideas being independent, we can synergistically do it together, and we can drive science much faster. However, larger advances are almost always individual, and that goes back to the creativity. Because the big one now are things like CRISPR-Cas, where you can change the genome really quickly. That was done in 2 labs. The intellectual property has been a fight for the last 2 years, because the two different labs have been trying to figure out who should make money off it, and in the end, probably nobody. Transfer from the individual to society, again, it goes back to the idea is if you're in your own lab and you're not transferring it to society, whether society is your group of researchers or society in general, I mean, that's something that's important. And constant review and revision results from these interactions. You get a paper, it gets rejected, or it gets asked for revisions, you revise it. You get a crappy score on a grant, you revise it. You get a better score, you revise it. You get it funded. Okay, so the idea is that the community is there to make sure that you're trying to put out the best science possible. And if you can do that, then that's fantastic. Because then you get more bang for the buck. And again, none of this is our money. This is all of our collective money. So we are responsible to society to make sure that we do the best we can with the money. So again, we kind of talked about this. Curiosity, intuition, creativity are important. And then judgment and how you use these characteristics influence everything we do. Obviously, if we don't, we could have the best experiment in the world. The data can be phenomenal. And if you interpret it completely wrong, that's an issue. Because again, then all of that is wasted. But if you go out and present it in a forum, whether by its poster or oral presentation or something, someone can get up and come and see you and say, hey, what about? And then you're like, oh my God, that's right. And then it starts, not only does that change the way that data is interpreted, but now you have a collaborator. And that's really cool. Because the more, in my personal opinion, the more collaborators, the better. I think it drives my lab crazy, but they seem to be happy some of the time. So publication do's and don'ts, when we go back to this property. Prior to publication, research is intellectual property. On this campus, your intellectual property is owned by campus, state, period, okay? The idea that you're gonna take your work and you're gonna go start a company and you're gonna go make $1 million, campus will go, oh no, that's not how it works. Patenting must take place prior to publication. If you publish something, there is nothing patentable because it's in the public domain. And what's really interesting, and a lot of researchers don't know, is that if you get NIH money, the state has a hand in it, but the government has a hand in it too. And a lot of times what happens is the government will just grant you temporary permission to use your own data. And as long as you inform them that you've put the patent process started. If you don't tell the NIH that you did it, then they get really upset. Because they're spending money to put the technology into the public sphere. Because they know it's all tax money who goes to us to do science, to then help science. And if you skip that part back, you know, they have this idea of bench to bedside. You know, it has to come back and help the community. And it protects us again, because I can go to, you know, MedImmune or BD or any of the other big companies and say, I have a great idea, and why don't you just, you know, take this idea and run with it? And you can't do that because, again, the intellectual property is campuses. And then post-publication, you have an obligation to share your data in even samples. Depending on where you publish, it's stated in the rules and the requirements of journals that if someone else says, hey, Bob, I want your strain XYZ, I am legally responsible to send them XYZ. It turns into a problem sometimes, but if you're really worried about things, you can get an MTA signed or you can get something else signed so that you make sure that what you give to them only stays with them and then they can't go out and sell it to a company. But again, that might slow things down, but you have a scientific responsibility to make sure that your stuff gets out there. And the other reason why you want it out there is you want other people to prove you were right or wrong. No matter how many times you reproduce something, if somebody else can't reproduce it in another state, country, city, whatever, that becomes an issue because then how does anyone believe globally your data is important? So there's a lot of ethical problems that arise because of publication. This also will come back to the idea is that there's a number that you need to achieve in papers before you can go up from assistant to associate, associate to tenure to full professor. They're freely given out in campus. We know what the numbers are you're supposed to hit before you go up for promotion. So a lot of times what will happen is people will choose the number over substance, put out a paper, but I have 52 papers, but it looks good on paper. As a statement says, more people can count than they can read, because a lot of times, how many papers? Oh, okay, I looked at your CV, it's 52 papers. If you want to go to all these new indices, the H and the I's and the other numbers, and what was the impact factor from the journals, and you average that together and you get a number, and boom, you're wonderful. Well, it doesn't work that way, but publishing the data in 2 journals doesn't happen so much in America, but sometimes it will happen where they will just change the titles, they'll change the figures around, and they'll publish the same data. That's getting harder to do because most of the journals now have the ability to scan papers very quickly and look for similar figures, similar writing, and everything else like that. Obviously, it's clearly wrong, and this again is done to increase the number of publications. There's a lot of these pay-to-review journals that are very small out there now, which promise you a 1 week or a 2 week turnaround time if you give them a bunch of money to review your paper. Those again are ways for people to get around the peer review system, and that it's not so much a problem in Europe and America, but in certain parts of the country where science is just starting to develop and science is just starting to explode, that they're really looking for these numbers so that they can advance more quickly in their careers. And then this is something I learned when I was in grad school. Always publishing short papers with little detail is not as good as a full paper. Tell the story. Take the time to tell the story. Because if you tell the story, in my opinion, the biggest honor that you can do for your paper is that when you go to another school to give a seminar or something or whatever, one of the students says, hey, yeah, we used your paper in Journal Club. And that really is the biggest stamp of approval, because if someone is taking the time to go get your paper, and then they say, but in this figure, what was this, but I really like this, because they took your paper and they dissected it. And the whole idea, if they can dissect your paper and find flaws, tell me what the flaw was. I have no problem with that. Or if they think there's a flaw, how can we work through this idea that it really wasn't a flaw, and maybe we should just talk, and I can tell you what we were thinking at the time. And so that for me is the greatest honor, is having your paper in Journal Club. People make justifications for a million reasons. What happens if someone scoops me? If there's many labs doing the same thing, sure, I can completely condone a smaller paper. Or if you think you're at the same level or at the same speed, or depending on the labs, PI to PI should talk to each other. Because the biggest thing we can do is do the same work twice or 3 times, because all it does is it hurts the students or the postdocs who are doing the work, because somebody will eventually lose out. Maybe somebody's a little ahead and they're missing a little piece of data that you have, and combined it makes the paper better. At least the student in the lab that is adding a small amount can get some credit, because if this big paper goes out, then this is now moot and they can't publish at all. And that's really bad, because you could be 2 years into your PhD career and find out that somebody scooped you and you could have been doing this stuff together. So in my opinion, that's the way I'd like to see things, is more people talk to each other and try to collaborate. And at least in the world that I work in, the research world, area I work in, we're very good about talking to each other. Students and postdocs need publications now. That's obvious. My funding agency wants to see publications before they renew. That's a big one too, because if you put in preliminary data that's not vetted by peer review, it's cute, but it's nice. But if it's vetted by peer review, then people go, it's okay, and then they move on to what the next data is. And so the whole idea here is, but the problem is, if you've already done all the data that you propose to do in the grant, they're not going to fund you to do what you did. So it's a problem. I'm giving up this project, but I've got enough to publish something. We call this orphan data in the lab, and we hate orphan data. So sometimes you try to take orphan data and you try to put it into a note, something small that will get out there, but at least if it goes in as a note or a small communication, then what will happen is people will know it's not a full story, and then they can build upon it. I mean, one of the things that we absolutely don't do in science, because it's kind of frowned upon, is we don't publish negative data. And a lot of times, some negative data out into the community would be very advantageous so that you don't do the same stupid thing we just did and waste money. But there's really no way to disseminate that, unfortunately. So one of the things that's interesting is we do have BSL-3 labs on this campus. They are select agent BSL-3. So that's basically sensitive research. It's highly controlled and highly regulated. We have permission through the DOJ and FBI and CDC to have the organisms we have on campus. To the best of my knowledge, is that there is no secretive research allowed in the University of Maryland system. Everything we have to do, that we do has to be able to be published, or it cannot be done on campus. It may have to go through, if I'm working with the Army, or if I'm working with somebody, they have a chance to review the paper, but they can't block the paper, you know? And we saw that with some work on campus for the anthrax work, 8 or 9 years ago, where the research was done, it was passed to the government group, and then it was eventually allowed to be published, but it has to be able to be published in the state of Maryland. And then should the research be done at all, if dangerous, we have committees on campus. The IBC looks at all of this stuff. Should we be able to do certain types of work that might take a virus from an animal virus only to be able to cross over to humans? If the work is ethically done, sure. And then we also have another committee called the Dual Use of Research, the DIRC. And we go through and we try to understand, is there any adverse effect of doing this research on the community? And if there isn't, or if it can be controlled, or if the risks can be mitigated, then science should go forward. But that's something that's done on a committee level, which the IBC has up to 25 people from every corner of campus and the VA, and we also have community residents who sit on our committees who are allowed to voting members who sit on our committee who are allowed to put input too. So this is a big one, especially if what you're trying to do in your mind has any value to the community. So let me see where I am here. This is my disclosure statement. We started a small company a year and a half ago called Patagon. And anytime I present any of the work that deals with what Patagon does, I have to put this up, saying that I have a financial stake. And this is language the language is actually longer than I need, I was told by OTT. But it's better to be over the top to make it very clear what you are. As long as you disclose that you have this disclosure statement, and especially if you go to a clinical meeting, it's the first slide that they're required to do. I get consulting money from XYZ. I do this for XYZ. And I also have a company with XYZ. So when you get into this, you have to put a conflict of interest through the campus. And this goes through your department, through your dean, up to the campus, up through Dr. Gerald, up through Dr. Perman, and then once it's all signed, you can then commence starting this company like we did. But here's the problem. Multiple values may compromise scientific judgment. A good example of this was they were doing some of the initial gene therapy work, and the researcher had a company who was making the vectors that they were using for gene therapy. They did some incredibly questionable things to get to the first data, to get into the first patient, and the patient was given something that overwhelmed their immune system, and the patient died. When they went back and took apart what had happened, there were so many failures, this is kind of pre-conflict, that they could see that they did all these things wrong because the researcher was also the owner of the company, and everybody didn't know it. And the researcher got severely reprimanded, but he's still doing research. And I won't disclose who it is. The financial interest in a company might influence how your data is interpreted. Oh, it's fine. Come on, it's no big deal. This is just one mistake. Therefore, this can't be right. If you're writing a paper now, you have to disclose your financial interest too. So when you referee a paper that scoops your work, you don't want to make sure that, oh, I'm doing the same thing and I got a company. I don't want to knock this person down because all of a sudden they're going to be farther along than me. And again, most institutions, not all institutions, have a COI policy to follow. And every year you have to update it. It's not just you did it once. Every single year, if you don't send your COI in, the COI office starts sending you emails over and over and over until you get it done. And it's not that they're being bad. It's that they're doing their job, and you need to do your job if you want to have a company and you want to do this stuff with with something you generate on campus. It's a pan balance, because a lot of times we think we're going to go out and save the world, when probably we should be better back just in the lab than doing good basic science. So that's that. So what constitutes research misconduct? And this is straight off of university: fabrication, falsification, and plagiarism. Plagiarism is the hardest one. Fabrication and falsification of data can be found very quickly. A lot of times you'll take a gel and you'll start mixing and matching and turning bands, or you'll take lots of slices from different gels, you can combine them together. Photoshop and Adobe and all these other programs are lovely, though I've seen ways that they're easy to figure out. I was shocked to see how easy it was to figure out, which is great for science. Plagiarism is harder, because we can even plagiarize ourselves. Because if you put out a paper and then you use the same exact paragraph in your next paper and your next paper, it becomes really hard. But there's only so many ways I can describe in the introduction what I do. You get to the point where you're just bouncing your head against the wall and you're like, all right, this sentence and this sentence and this sentence. So sometimes our work is very similar in the introductions, but then when the results come and the discussion come, then it gets a bit better. I know that my chair is an editor of the journal Pathogens and Disease, and every single paper that comes into Pathogens and Disease gets scanned for plagiarism instantly. And if they found there's a significant amount of plagiarism, I don't know what number they consider significant, it just gets sent right back non-review saying, you do realize that you have stolen these pages and these many sentences in this, and then they have to address what they've done.
What about materials and methods?
Oh, yeah, I use those over and over again. You have no choice. I didn't change the method in the last 10 years, so you're getting the same thing.
But that's not considered plagiarism?
No, well, by the standard word, yes, but there's no other way to change your method. Because the other way you can do it is, please see my previous work. And you give a reference, and I hate that. Because in the day and age, and in America and Europe, it's really easy to go get the journal. But if you're in some parts of Asia or you're in Africa, they can never get those journals. So it's much better just to take your same chunk of methods and just put it again. And that way they can read it. Because a lot of times, it used to be different where when you publish, someone would email you for the reprint, and then you would send them the reprint or the PDF. Nowadays, there's sci-hub whatever, wherever it's being hosted now, where a lot of people in the developing scientific world can go ahead and get these journals for free. But again, how many internet emails do you get every morning when you show up? You get so many junk ones, but then there's still a significant number that you have to answer because people have very simple questions that they don't know. So, yes, I understand with the issue with methods, but we use the same ones over and over again. I can't think of any other way to do it. The consequences. Minor ethical lapses. It's handled within the community. If it's a mistake, if it's an honest mistake, it's handled by peer review, administrative action, or tenure review. Scientific misconduct can happen at a lot of different levels. If it's harm to other people, medical research, then it can go to the IRB, the IBC. If it's animals, it'll go back to IACUC. It's not unknown where the IACUC reports back to NIH that there's been a mistake. The Institutional Biosafety Committee, when there's a mistake, we report back to NIH. We're required by law to acknowledge that we made a mistake. The mistake is then accepted, and our response to the mistake is either accepted or not accepted by NIH, and then they open the book or they close the book. It's really easy. And then the procedures that we have, as you can see, there's Sarah and Stefan, and they if they come to your door, it's probably more serious than you'd probably want. So if you need more training, this type of training is available on campus. COI, they will help you through COI over and over and over until you get it right. That's easy. Policies regarding humans, IRB, IACUC, IBC, all this stuff is online, and we're required to take these courses online, 1 to 3 years. Your mentor-mentee responsibilities and relationships can help you through this, and then you'll understand peer review and data acquisition and research misconduct and authorship and all these things by doing it or by asking for help. As I said, the students and the postdocs get whatever it's called. It's called CIPP 907, and that's the ethics class. It's a whole year's ethics class. And You know, every student has to take it, every postdoc has to take it. It's a requirement, especially if you're on a training grant. It's a requirement for most of the programs. And then what should we take out of science? This is really what we need. We need to do good. We need to add value, because a lot of times what we do is as I said, a lot of what we do in the lab fails. So when it fails, we have to be able to go forward, and what goes forward has to be good, and this is how we train the next generation of scientists. And obviously, honesty and objectivity are always good, you know. That's all we have in science, is our honesty and our ethics. And if you lose them, you will lose the community, and no one will want to do work with you anymore. So, thanks. Yes?
Oftentimes, it's difficult to draw the relationship between laboratory science and long-term results. For instance, in clinical research or post-approval. Can you just talk a minute about how scientists and how individuals can make that leap from good quality laboratory research or not, and the potential long-term consequences down the road?
Positive or negative effect? Right. Positive, if you think you have something good, you go over to Office of Technology Transfer. And you meet with those people and you put a disclosure in, and then if there's something of value, they will expose you to the non-academic community, industry, other folks who can then potentially come and take your ideas and move them forward. So that's a disclosure through the patent process, and they're very good over there. You'll get assigned a manager. In my case, it's Melissa Blackman, and they go out and they work for you that way. If you want to start a company, then you license the technology back, and the university is very amenable to starting, Maryland-based companies, because both it looks good for them and it looks good for us too. If your company fails, they'll just take back the technology and they'll shop it to somebody else. So there's a way to do it yourself, or there's a way to go out forward other ways. It's a long, long process. So don't assume that anything is going to happen overnight. We've put in patents 5-6 years ago. They're still going through the process, and it's fine. Adversely, going out and blowing your own horn and going out and making grandiose statements about things always will blow back in your face. And then you have to deal with it, and then your department has to deal with it, and then your dean has to deal with it. And if your dean's dealing with it, then we're in trouble. So it's a lot of times, in my personal opinion, it's better to let the science go out forward and let that be the leader, instead of the person being out there screaming from the highest tree saying I'm the best. But again, that's my personal opinion.
A follow-up to that. Then can you speak about the importance of record keeping in labs? Oftentimes we come across just sloppy record keeping, if you will. And can you talk about the vulnerability to the individual scientists in that case?
Mm-hmm. In a perfect world, there's a perfect notebook. We come in and we tell the students and everybody, this is how we'd like the notebooks done. It's very difficult because there's two ways of doing it. A lot of times notebooks are moving to electronic, and that makes it a much more difficult thing to deal with. But in industry and non-academic science, everything's still done on paper, because you have to have a physical record of what you're doing and when you did it, and yada, yada, yada. The notebook is great, but having the primary unadulterated data is better. If you've scanned something, if you've taken a picture of something, if you've done a primary reading off of an XYZ instrument, you better have the rawest of raw data. Because a lot of times what will happen is, and people get in trouble, is people will come to lab meeting and say, look, here's my beautiful figure. It's all done. It's ready. It's publication ready. And it's a beautiful figure. But as the PI, you'll say, where did the data come from for this? Because people will start splicing bits and pieces together. It happens at the highest levels of NIH, where one of the leaders in NIH, there were gels that were turned upside down in publications. It's clear as day it's upside down, but the PI never looked at the raw data. So for me personally, a lot of stuff we do, the methods are very similar, but it's the raw data that's the absolute gold. Because if you screw with the raw data, then you've started fabrication and fraud immediately. So there's got to be a place, whether you store it electronically or on paper or a physical copy of your raw data. I mean, a lot of the sequencing data is obviously, it's gig and gigabytes of data, if not bigger. So, but that raw data has to be stored somewhere. And then notebooks belong not to me, not to the student, not to the postdoc. Every one of the data notebooks belongs to campus, period. You don't get to take your notebooks with you. You can make copies. But at the same time, and the reason being is if NIH or Office of Integrity Research comes along, they want to see the primary data. They don't want to see, I made this figure and this is what it is. So, yeah, so data is data, and it belongs here. And it is a problem with electronics, because I actually like students keeping electronic notebooks, as long as I know where the primary data is. Because notebooks take up physical space. We have tens and tens of feet of notebooks over the last 15 years.
With that electronic data notebook, though, that comes a need for security, backup.
Well, you should have all your computers on some form of an external backup, just in case computers die. So all the computers have some form of an external hard drive on them. We're a Mac lab, so Mac just dumps it to it every hour. Yes?
So isn't there an issue with keeping electronic notebooks, though, that they need to be kind of like an auditing trail, because electronic things can be edited and changed, and that's always, I work in clinical research, and I'm still clawing to my paper because it's very obvious who makes corrections, and then some people use Excel spreadsheets, which you can lean on the keyboard.
Yeah, but there'll be a date. I mean, there's underlying records that can be determined, and again, that goes back to Sarah's office, and I've seen some stuff being done that can be then discerned. I mean, it's really, really hard to get rid of electronic data, as I'm told.
Okay.
Yeah.
At the minimum, from a technical point of view, at the minimum on that file, Excel, word, whatever it is, there's metadata that's in the file that you as a user won't see. It's very apparent to somebody who knows.
Good to know.
Yeah.
So,
Yeah.
No, it is good to know, because I'm
and especially if
always,
you're using like a SharePoint or any kind of,
A OneDrive or a Google Drive.
well,
Yeah.
those do track.
Yeah.
because it tracks all the changes, and most of those will keep versioning on those
Mhm.
as well as metadata. So you
So
can say,
encourage use of
yesterday
those.
I made the change and today you made a change, and it's listed right there.
That's good.
I mean, we're going to have this problem no matter what. There is so many companies out there selling electronic notebooks. They're all pretty bad. Well, they're very cumbersome. They want the notebook to be paper-like, without in the electronic space. As long as you organize things, and obviously when anyone leaves the lab, I just grab a whole copy of everything, because I have lab computers that obviously most of the stuff in the lab gets done, but then there's people who will take stuff on their personal computers back and forth, as long as there's a copy on the lab computer. But I'll just make a full copy of that, and I'll store it on an external hard drive. Because a lot of times I want to mine that data later anyway. Because most students do way more work than what they put into their thesis, and that's a good thing in my opinion. So, yes, I have people in my lab. We're still publishing their papers. Okay. Well, thank you.